charge and
body
how charge is distributed
distribute
over a surface.
surface
ठीक है, और क्या लगता है आपको चार्ज कैसे डिस्ट्रीब्यूटेड होता है? Yes, uniformly or non-uniformly. So in charge distribution, we talk about uniform charge distribution. This is uniform charge distribution. In uniform charge distribution, you can see that for different figures, charge is equally spaced, right? While when a charge is not accumulated in some parts but is spread uniformly, then it is uniform charge distribution. On the other hand, non-uniform charge distribution, we have unequal distribution of charges. So here you can see at some areas, charge density is greater than the other areas, right? So more charge is accumulated at the curves and sharp points. This we had discussed in previous class as well. So charge density, it is quantitative representation of charge distribution, how charge is distributed. ठीक है, तो डेंसिटी क्या होता है? डेंसिटी इज मास अपॉन वॉल्यूम, मास पर यूनिट वॉल्यूम. चार्ज डेंसिटी क्या होता है? चार्ज डेंसिटी इज चार्ज per unit volume. As density is mass per unit volume, similarly charge density is charge per unit volume. So we take volume when we take solid figures. When we have solid shapes, then we say that it is charge per unit volume. But what if we have charge distributing over the surface of when we have line charge distribution or aerial distribution, then we take length or area. It depends upon the dimensions of the charged conductor. It depends upon the dimensions of the charged conductor, right? So here charge is present in a volume, and here we take mass present in a volume. This is the mass density and this is charge density. Okay, so quantitative representation of charge distribution is called charge density. Easy. Now we have different types of charge density: linear charge density, surface or superficial or aerial charge density, or volume charge density. So there are three types of charge density, right? So first one is linear charge density. Linear charge density is denoted by the letter lambda. It is denoted by the letter lambda. So charge per, because देखो यहाँ पे we have this word linear along the length. So charge is distributed along the length. Charge per unit length. Okay. Charge is distributed along the length. So it is charge per unit length. So lambda is equal to charge upon length. Okay. So for a rod, if we have a rod of length L, then it is Q by L. Okay. If it is a rod of length L, then it is Q by L. And for a circular ring, if we have a circular ring of radius R and charge Q is distributed over the surface of the ring, then it is 2 by 2 pi. Because length of the ring is 2 pi r. Length of the ring is 2 pi r. So it is Q by 2 pi r. Okay. So if we consider a small line element, then we take small charge. Small charge in small line element. Yes. So it is dq by dl. Okay. Charge on small element upon length of the element is dq by dl. Unit of lambda is coulomb per meter, because unit of charge is coulombs and that of length is meter. So it is coulomb per meter. And you can also find dimensions of the linear charge density. How will you find dimensions of the linear charge density? Charge is current. You know, current is charge upon time. So charge is because charge is current into time. Electric current is a fundamental quantity and time is also a fundamental quantity. So if we write the dimensions of charge, so we will write I and capital T, right? And for length, dimensions of length is L. Dimensions of length is L. Now because lambda is charge, if we have to find dimensions of lambda, so we'll write dimensions of charge divided by dimensions of length. Dimension of charge is I, T, and that of length is L. Dimensions of length is L. So it is L minus 1, I1 and T1. And here we have no mass. So in surface charge density, charge is distributed over a surface. Okay? Because it is distributed over a surface, so we take area. We find charge per unit area here in this case, and it is denoted by the letter sigma. It is denoted by the letter sigma. Okay, so a surface has only area, and so we take area, and sigma is charge upon area. So for a disk, if we have a disk, and in a disk, suppose charge is distributed uniformly over the surface of a disk, and its radius is r, and charge is q. So we take sigma as q by, because it is a disk and it is circular in shape. So area of circle is, area of disk is pi r square. So it is q by pi r square. Sigma is q by pi r square. Okay. And if we have a small element, if we consider a small element over the surface, for small element, we have small area, and in the small area, small charge can be is accumulated, right? So it is dq by dA. It is dq by dA. Now, because unit of charge is coulombs and that of area is meter square, so charge unit of surface charge density will be, yes, it is coulomb per meter square. And what are the dimensions of surface charge density sigma? Yes, I1, T1 and L minus 2. Very good. So this is the dimension of surface charge density. Easy. Now let's move to, should I? Volume charge density. Volume charge density is denoted by the letter rho. Rho. It is denoted by the letter rho. And charge per unit volume, because here we have volume. So we take charge per unit volume. It is denoted by letter rho. Sphere has a volume, cube has a volume, cuboid has a volume, right? These figures, three-dimensional shapes, we find volume for three-dimensional shape. So rho is charge per unit volume. Okay. So for a sphere, what is the volume of a sphere?
4 by 3 pi.
Very good, शाबाश. 12th class के बच्चे नहीं बताएंगे तो कौन बताएगा? स्फेयर का रेडियस होता है r, चार्ज होता है q, and volume of the sphere is 4 by 3 pi r cube. So simply put the value of volume here. So we get rho is equal to q upon 4 by 3 pi r cube. ठीक है? And this rho is equal, if we take a small volume, so in a small volume, small charge is there, right? So it's dq by dv. And what is the unit? Unit. Coulomb per meter cube, because volume is measured in meter cube and charge is measured in coulombs. And what are the dimensions? L minus 3, I1, T1. Easy? Yes? साथ साथ लिखते जाओ फटाफट. आप लगा दो, ब्रैकेट नहीं लगा हुआ तो स्क्वायर ब्रैकेट लगाना है. Yes. So now let's summarize what we have read. We have done three types of charge densities here: linear charge density, surface charge density, and volume charge density. Linear charge density is denoted by letter lambda, surface is by sigma, and volume by rho. Okay. Examples are, if we take broad, we find linear charge density, and what is the relation? Lambda is equal to q by L. What are the unit? बताओ. Coulomb per meter. Dimensions L minus 1, I1, T1. Good. Formula Q by L. Again the same thing. General formula dq by sigma. Surface charge density. Example. Disk. Yes. Anything you can take. Any two-dimensional thing. Okay. Unit is. Dimension is this. Okay. And it is dq by dA. Formula for this particular thing, na, for disk is pi r square, but this is q by a, and general formula is dq by dA. Okay. Volume, we're taking sphere this time. Okay. Example is sphere. It is q by v.
L minus 3 m.
Okay. Shabash. 4 by 3 pi r cube. नीचे क्या आएगा? Last dq by d. Very good. ओके, ये तो बता दोगे, बच्चों वाले क्वेश्चंस क्या पूछ रहे हैं 12th क्लास के बच्चों से?
D part sigma.
सिग्मा, राइट। नेक्स्ट,
Coulomb per meter.
ऐसे से क्वेश्चंस अगर जेई में आए तो मजा ही आ जाएगा हमें, है ना? एनसीईआरटी में डाल दो, सीबीएसई में आ जाए तब भी आ जाए मजा, बट आते कहाँ है?
D part.
L minus 3 M naught T1 I1, अब ये करके दिखाओ। A long thin rod of length 50 centimeter has a total charge of 5 millicoulombs uniformly distributed over it. So we have a charge of 5 millicoulombs. How many coulombs are there in millicoulombs? 10 to the power minus 3. Fine. So you can find the charge in coulombs, and length is given. Length of the rod is 50 centimeter. So 50 centimeter has to be converted into meters first, and then you have to find the linear charge density. सृष्टि समझ आ रहा है?
Yes, ma'am.
इजी लग रहा है?
Yes, ma'am.
Good. The Q is 5 millicoulombs. It is 5 in 10 power minus 3 coulombs. 10 power minus 3 coulombs. Length is 50 centimeter, 0.5 meter. We have to find linear charge density. It is Q by L. You simply have to put the values and you'll get your answer. Write the units as well. Coulomb per meter. Okay. Electric charge done. We have completed electric charge today. Okay. Party. अब start करना है Coulomb's law. Next topic. Have you done this? एक क्वेश्चन और कर लो, उसके बाद खत्म करते हैं इसको. We have a cuboidal box. It penetrates a huge plane sheet of charge with uniform surface charge density. So we have a cuboidal box here, and it penetrates a huge plane sheet of charge. We have a plane sheet of charge with uniform surface charge density. Charge density is given, it is sigma, because it is in coulomb per meter square, such that its smallest surfaces are parallel to the sheet of the charge. If the dimensions of the box are this, this, and this, then find the charge enclosed by the box. Question समझ आया? ये वैसा क्वेश्चन है, इसमें फोर्स निकालते थे ना, मतलब प्रेशर इज इक्वल टू फोर्स अपॉन एरिया करते थे, और क्यूबॉइड दिया होता था, फिर हम देखते कहाँ पे मैक्सिमम प्रेशर होगा और मिनिमम प्रेशर होगा, है ना? उस टाइप से आपने देखना कि आपने कौन सी दो बीच में चूज करनी है, लेंथ ब्रेथ और हाइट में से कौन सा आपने दो चूज करने हैं जिससे आपका एरिया आएगा. Smallest surfaces are parallel to the sheet of charge.
5 into 3.
We'll take 5 into 3. Smallest surfaces are parallel to the sheet of charge. If the dimensions of the box are 10 cross 5 cross 3, then find the charge enclosed by the box. The charge enclosed by the box is equal to charge on the portion of the sheet enclosed by the box. Okay? The area of the sheet enclosed is equal to area of the smallest surface of the box. It is equal to 5 centimeter cross 3 centimeter. It is 15 centimeters square. So when we convert centimeter square into meter square, we simply multiply it by 10 to the power minus 4. This is how we convert. In 1 meter, we have 100 centimeter. In 1 meter square, we have 10,000 centimeter square. Okay, 10,000 is 10 raised to the power 4. आता है ना conversion, basic conversion है ये. Charge density is given. Is 2.5 in 10 power minus 2 coulomb per meter square. Charge enclosed, because charge density sigma is Q by A, charge upon area. So charge will be charge density multiplied by area. है ना? Charge is charge density multiplied by area. Charge density is given, area is given. You just have to multiply these two and you will get this. So now we have charge in 10 power minus 6 order. 10 power minus 6 is micro. Minus 6 is micro, no? So charge is 37.5 microcoulombs. 37.5 microcoulombs. Easy? Thoda easy. Srishti, you're writing everything?